Hello students, today we will start with Ohm's law, which is one of the important topic of chapter electricity. First we will start with statement of Ohm's law. Ohm's law क्या कहता है? According to Ohm's law, potential difference is directly proportional to the current in the circuit. That is, suppose if we take two ends of a conducting wire, then potential difference is V here and current in the circuit is I. V represents potential difference and I represents current. I represents current. Unit of potential difference is volt and unit of current is ampere. According to Ohm's law, potential difference in the circuit is directly proportional to the current. That is, by statement, we can say that potential difference is directly proportional to the current. This is the statement of Ohm's law. If we remove this proportionality sign, we have to put a constant here and constant will be Ri. That is, according to Ohm's law, V is equals to Ri. R here is constant, R here is constant which we have used, and R represents resistance. R represents resistance. What is this resistance or R? Resistance here is the obstruction or the hurdle offered by this wire when current of I is traveling through these two ends and potential difference between these two ends is V. R is resistance. We will take it separately. What is resistance, which we have discussed just now? Obstruction or hindrance or hurdle in the passage of current. That is, we can say resistance is obstruction or hurdle in the passage of current. That's why its symbol is also in this manner. We'll represent resistance in this manner. Just see, we are in a straight line and suddenly a zigzag path comes. Our speed will get slows down. Therefore, resistance is also represented in a similar manner through a zigzag line, which represents that whenever resistance is offered, current will get reduced in the circuit. According to Ohm's law or statement of Ohm's law, which we have derived, V is equals to IR. We have just derived it. Potential difference is equals to IR. If we have to find value for R here, it will be V upon I. Observe this term. Resistance is inversely proportional to current. If resistance will increase, current in the circuit will get decrease. That is, if obstruction or hurdle in the passage of current will increase, current will also get decreased. Resistance, according to this formula, is volt. Potential difference, unit of potential difference is volt, that is 1 volt divided by 1 ampere. So we can also say that resistance is the ratio of potential difference and current, that is R is equals to V upon I. Unit of potential difference is volt, unit of current is ampere, that is the ratio of potential difference and current. One important question can be there in exams. Define 1 ohm, that is what is the unit of resistance. Unit of resistance is represented in these two manners, that is ohm by symbol, or we can just write ohm. Now what is 1 ohm, or how to define 1 ohm? By the simple formula we can say that resistance is equals to 1 volt upon 1 ampere. So we can say that 1 ohm is equals to 1 volt upon 1 ampere. We can represent it in this manner, that is 1 ohm is equals to 1 volt upon 1 ampere, or we can also define it in language form, that is when potential difference of 1 volt is there between two terminals or two ends of a wire and current of 1 ampere is traveling through it, then the resistance offered by that wire is 1 ohm. Or simply we can write 1 ohm is equals to 1 volt upon 1 ampere. So this is resistance. Now we'll discuss on which factors resistance depends, or which factors affects resistance in the circuit. On which factors resistance depends? In this, first point is length of wire L. Second point is area of cross section A. And third point is type of material, we'll define it. And fourth point is temperature. So factors which affects resistance in a wire can be in these four manner, that is length of wire, area of cross section, type of material and temperature. First we will discuss about these two conditions, that is length of wire and area of cross section. Resistance is directly proportional to the length of wire. Now what is the length of wire? Wire is in the form of a cylinder Now this is the length of wire. If length of wire is increased, अगर हम वायर की लेंथ को इंक्रीज करेंगे तो रेजिस्टेंस भी इंक्रीज होगा. सपोज अगर 1 मीटर लेंथ वायर का रेजिस्टेंस 1 ओम है, सेम मटेरियल का 2 मीटर का वायर लेंगे, इट्स रेजिस्टेंस विल बिकम 2 ओम एंड इट विल increase in this proportional manner only. So we can say with this first equation, that is resistance is directly proportional to length of wire. If length will increase, resistance of wire will also get increase. In second term, we will take area of cross section. Now what is area of cross section? Length. Suppose if this is a wire, we are considering this as length. This is length of wire. Now what is area of cross section? There is a difference between area and cross sectional area. Suppose if we cut this wire, then the face of it will give area of cross section. That is, this part will give area of cross section. Area of cross section is inversely proportional to resistance. That is, if area of cross section, if thickness of this wire will get increased, resistance will get decreased. And if area of cross section will decrease, resistance in the wire will get increased. Third factor is type of material, and we have to discuss this factor in detail. If length and area of cross section are there only in wire, अगर suppose खाली दो ही condition होते हैं length और area of cross section के, then we can use any type of material because resistance offered will be same. Then why we are using different types of material in wires? हम कहीं पे कॉपर वायर यूज कर रहे हैं, कहीं पे एल्यूमिनियम वायर यूज कर रहे हैं. अगर हम घर के बाहर देखें तो एल्यूमिनियम वायर्स हमारे पास लगे रहते हैं, घर के अंदर हम मोस्टली कॉपर वायर्स यूज कर रहे हैं. व्हाई वी आर यूजिंग डिफरेंट मटेरियल? बिकॉज each material also offers some internal resistance, that is type of material, and it plays an important role in passage of current. So third point is type of material. We take it separately. If we combine equation 1 and equation 2, we can say that resistance is directly proportional to L and inversely proportional to A. Again, a proportionality sign is there. If we have to remove this proportionality sign, we again have to put a constant, and we use constant here as rho. This symbol represents rho, and it represents resistivity, or we can say specific resistance or internal resistance of the material. What is this rho? It represents resistivity or internal resistance of the material. Value for this rho, from this formula only we can say that resistivity is equals to resistance multiplied by area of cross section divided by length, A multiplied by R divided by length. Unit of resistivity, unit of rho, unit of resistance is ohm, we'll put it here as ohm, multiplied by unit of area of cross section meter square divided by meter. Meter and meter gets cancelled, its unit will become ohm meter, that is ohm multiplied by meter. Internal resistance of the material depends on this term. Or directly, if we say that area of cross section is 1 and length of that wire is also 1 meter, then resistance is equals to resistivity. If in this formula only we will say that resistance is equals to resistivity if unit conditions are there, that is area of cross section is 1 meter square and length is also 1. So this is the third condition on which resistance depends, or the factor which affects resistance, and this depends on length and area of cross section. Now fourth important condition on which resistance depends. Temperature. How resistance depends on temperature? Resistance is directly proportional to temperature. That is, if temperature will increase, resistance will also get increased, and if temperature will get decreased, resistance will also get decreased. नाउ रीजंस फॉर इट, टेम्परेचर के बढ़ने से रेजिस्टेंस कैसे बढ़ रहा है और टेम्परेचर कम होने से रेजिस्टेंस कैसे कम हो रहा है. We have already discussed these 2 points. Suppose if a wire is there, we'll take the same wire. If we increase temperature, what is the property of metals? They will expand. When heated, metals will expand. When metals will get expand, increase in length is there and decrease in area of cross section is there. What we are discussing here, when we increase the temperature, increase in length of the material will get increased and area of cross section will get decrease. These two conditions which we have already discussed, if length will increase and area of cross section will decrease, in both the cases resistance of the material will get increased. If length will increase, resistance will increase. If area will get decreased, resistance will also get increased. So in both the cases, whenever temperature will get increased, length and area will also get affected in this manner, and in both the cases resistance of the material will get increased. When temperature get decreased, that is at a very low temperature, there is one term or one condition which we will say superconductivity. When temperature will get decreased and at a very low temperature, we can attain a condition of superconductivity. That is, resistance of that material will also get decreased and becomes negligible, and conductance, that is current conducting through that wire, will gets increased. This condition can be attained at a very low temperature, and this condition is known as superconductivity. So these are some of the factors on which resistance depends or which can affect resistance. First is length, second is area of cross section, third is type of material, that is resistivity or the internal resistance, or we can say specific resistance. And fourth condition which affects resistance of the material is temperature. And we have discussed about temperature, that resistance is again directly proportional to temperature. Now we take some numericals on the basis of Ohm's law. Question first. Resistance of the material is 16 ohm and current flowing through it is 2 ampere. Calculate potential difference. In this case, we use Ohm's law. Potential difference is equals to IR according to Ohm's law. Potential difference is equals to 2 multiplied by 16, that is potential difference is equals to 32 volts. This is directly based on Ohm's law. Second question. In a given material of resistance 440 ohm, in a given material of resistance 440 ohm, potential difference is 220 volts. We have to find current flowing through the wire. We have to find current flowing through the wire. Again we will take same relation, that is V is equals to IR. We have to find current. I is equals to V upon R. I is equals to, potential difference here is 220 volts and resistance offered by that wire is 440 volts. This will become 1 upon 2, or we can say 0.5 ampere. So current in this condition will become 0.5 ampere. One more condition is there. We'll take one more question. Potential difference across two ends is 220 volts, and current traveling in the wire is of 2 ampere. We have to calculate resistance. Again, in these two questions we have used V is equals to IR. In this question again we will use this V is equals to IR. That is, V is equals to IR. We have to find resistance, which will become V upon I. Resistance is equals to, potential difference here is 220 volts divided by current here is 2 ampere. That is, resistance here will become 110 ohm. Resistance here will become 110 ohm. So these are some of the easy numericals related to Ohm's law. We'll take one more question related to internal resistance or specific resistance or resistivity. Important question on resistivity. A wire of length L is given to you and resistance of that wire is 4 ohm. What is given in this question? A wire with resistance 4 ohm. It is doubled on it. Now what is the meaning of doubled on it? We have a wire of 4 we have a wire of resistance 4 ohm of a particular length. Now we doubled on it. We put that wire doubled on it. That is, decrease in length is there. Resistance of this wire, that is, resistance is equals to rho L upon A. It is equals to 4 ohm. Now in next condition, we have to find resistance of the wire if its length is doubled on it. If its length is doubled on it, that means length will decrease by half and area of cross section will increase by 2 times. That is, a particular area of cross section of this wire is there. If we doubled on it, then area of cross section will get 2 times. Now we have to find this new resistance of the wire. Again, resistance of the new wire is rho, length is decreased by 2 and area of cross section will increase by 2. That is, it will become rho 1 upon 4 rho L upon A. Now, resistance is equals to rho L upon A and resistance of that wire is 4 ohm. So, new resistance of that wire will become 1 upon 4 multiplied by 4, that is 1 ohm. Now, this is an important numerical related to resistivity. This is an important numerical related to resistivity. We'll take some more numerical or practice questions in next class. Thank you.